Now we're going to look at some indifferences identities. These are the ones that you don't have to memorize as well because they'll be on a formula sheet for you whenever you have a test or an exam. But what you do need to know is how to use them. So for this in particular, they're really good for finding the exact value of angles that we are not used to finding. For example, with these formulas, I can find sine of 5 pi over 12. And usually 5 pi over 12, we would look at that and be like, that's not my one of my triangles, so I'll just use my calculator. Well, now you can actually do this without a calculator by using these formulas. So let's take a look and see how we do that. So say I want to find the exact value of sine of 5 pi over 12. The first thing you want to do is look for two pairs of angles that can add up to 5 pi over 12. I'm going to pick 2 pi over 12 and 3 pi over 12 because that adds up to 5 pi over 12. And the reason I picked those two ones is because I can reduce the fraction. And if I try to reduce this would be pi over 6 and then pi over 4. And these are the two angles that I actually know the exact value triangles for. If I pick something like this, pi over 12 and 4 pi over 12, don't write this down by the way. If I pick those, yes, they add up to 5 pi over 12, but do I know my exact value for that angle? No, I don't know anything for pi over 12, so I wouldn't pick something like that. Pick the ones that you can reduce, which is why I picked those ones. And in this step, I said to add up to 5 pi over 12, but you can also subtract to 5 pi over 12 as well. So if I did that, well, I can pick 8 pi over 12 and 3 pi over 12. Because if I subtract those two from each other, then I'll get 5 pi over 12. And I can also simplify this. This will become 2 pi over 3 and pi over 4. And I know how to evaluate those type of angles. So second step, decide which identity you will use, the sum or the difference. Well, for this one here, I would use the sum identity. I would actually use this one. So I'd plug in sine of pi over 6 plus pi over 4. If I want to do the subtraction one, then this one would go with the difference identity. So it'd be sine of 2 pi over 3 minus pi over 4. Either one will get you the same answer in the end, so it doesn't matter. I'm just going to use the sum identity. So I'm going to use this sine of pi over 6 plus pi over 4. And then I'm going to plug in these angles. So this is my A angle, and that's my B angle. So every time I see A, I'm going to plug in pi over 6. If I see B, I'm going to plug in pi over 4. So sine of pi over 6, cos of pi over 4, plus cos of pi over 6, sine pi over 4. So I already did step 3. I plugged the angles into the identity, and now I want to simplify and evaluate. So once I simplify this, so I'm calculating 5 pi over 12 right now. If I simplify what I have up there, sine of pi over 6, well, maybe I should draw my triangles to figure this out. So sine of pi over 6, that's opposite over hypotenuse, which is a half. Cos of pi over 4, that's going to be 1 over root 2, one of our triangles again. Plus cos of pi over 6, which is a root 3 over 2. And then sine of pi over 4 is 1 over root 2 again. So simplifying this, I have 1 plus root 3 as my numerator, and as my denominator of a common one is 2 root 2. And that's our exact value, and you just leave it like that. So the next example. It should say example 2 here. I wrote example 1 twice. Now this one, we have one that's already expanded from us, and we're trying to simplify it, so shrink it back. So if we took a look at our identities up here. We want sine sine minus cos cos. But if I look at here, I don't really have a sine sine minus cos cos. I have these two. So I know it's going to be either cos A plus B or cos of A minus B. It's going to be one of those two. Well, I don't want a minus in front of my cos cos because look at these two don't have a minus, right? So what I can do is try to factor it out first and then see where it takes me. So let's factor out the minus. Then I'm left with positive cos 3 theta times cos theta, and then minus sine 3 theta sine theta. Okay, now this looks familiar now. Cos cos minus sine sine. That's this one right here. Cos of A plus B. So I know it's going to be minus cos, and it would be A plus B. My first angle is 3 theta, and my second angle is just theta. If I simplify this, this would be cos of 4 theta. And that's all that they wanted you to do. Just write it under one trig function. And that's it. I'm going to do one that's similar to that, but in this case actually put the angle in for us so we can evaluate it. So this one's tan minus tan, 1 plus tan tan. So let's take a look. So it's tan minus tan at the top, and then 1 plus tan tan. That would be this one right here. So we know it's going to be tan of A minus B. So this would be tan, and we'll have a minus in between the two angles. Our first angle is pi over 2, and our second angle is pi over 3. Now I want to put this under common denominator, so I'll need 6 as my common denominator. That means I need to times this by 3 top and bottom, and this by 2 top and bottom. That'll give me 3 pi over 6 minus 2 pi over 6. And that gives me tan of pi over 6 once I simplify my fractions there. I know how to calculate tan of pi over 6. Just need to draw up my triangle. Okay, so tan is opposite over adjacent. That's 1 over root 3. And then we're done. We simplified it first and then evaluate at the end. All right, a different type of question now. Now we're going to do what we've been doing before with proofs. We're going to prove one side is equal to the other side. In this case, I'm going to go with my left-hand side first. And then I'm going to use those identities that we've been looking at before, the sum and difference one. So I'm going to expand this. And when I expand it, it would be cos pi over 2 and just cos x plus sine pi over 2 sine x. So that's just coming from our formulas. All right, so I can evaluate some of this. I know what cos of pi over 2 is. I can look at my unit circle. So pi over 2 is right here, and my point would be 0, 1. The first coordinate is my cos. So at pi over 2, cos will be 0. So 0 times cos x. And then at pi over 2 for sine, it's 1, because that's my second coordinate. So it'll be 1 times sine x. 0 times cos x, that's just 0. So I'm just left with 1 times sine x for the same thing as sine x. And that is my right-hand side. And then I'm done. Example 3. Now we have an equation, and we want to solve for x. As we can see, this can be simplified and reduced to just one trigonometric function. So if you look at our formulas, this would fall under sine 5x minus 3x. I'm just using the formula for the sum and differences. So this format of sine cos minus cosine is the same thing as saying sine of a minus b. Okay, and we know this is equal to 1. I don't need an equals on this side, I guess. Okay, I'm going to simplify this, so it becomes sine 2x is equal to 1. Now this becomes one of those multiple wrap questions that we've done before. I'm going to let theta equal to sine x. So what I'm actually solving for is just sine theta is equal to 1. I can draw it out of my unit circles to see when sine is 1. And sine is 1 is at pi over 2 because my point here is 0, 1, and the second coordinate here tells me that sine is going to be 1 there at pi over 2. So theta is pi over 2. But this is just one angle, right? I need two angles. So I'm going to do pi over 2 plus 2 pi. If you look at a domain, I don't want to minus it. So the other angle would be 5 pi over 2. And if you're still a little confused, I can explain a little further here. This is coming from the coterminal angle of pi over 2 by adding 2 pi to it. And when I do that, I would get 5 pi over 2. Okay, so I got those two angles. But I'm not done. I said theta is equal to that. I don't want theta. I want 2x. That's my original question. Okay, and then I'm going to divide both sides by 2. And once I do that, I have pi over 4 and 5 pi over 4. Those fit in my domain, and that's going to be my final answer there. And that's it for this section of sum and differences identities.